So in this video, I'm going to be talking about chapter 2 and measurements. And I'm going to go back to the first slide. All right, so this is chemistry and measurements. And the topics that are going to be covered here are measurements, measured numbers, and sig figs. And so in this video, I'm going to see how much of 2.1 I can cover, followed by the next video where I'm going to talk about the sig figs and continuation of measured numbers, sig figs. And then we're going to look at how to use the sig figs in calculations, and then define what prefixes and equalities are, what a conversion factor is, and then problem solving using those conversion factors. And the final topics are density and specific gravity. So measurements are something that are used all the time. We may or may not think about it. So here we can see a nurse taking the temperature of a patient, all right? She might have already taken his height and weight. Another measurement would be trying to figure out what the dosage of medicine is, and so on. So measurements are part of life. Even if we go shopping or we go to the grocery store to buy something, we are using measurements. We may or may not think about it consciously, but we are. So some of the math skills that are carrying over from chapter 1 are identifying place values, using those positive, negative numbers in calculations, calculating percentages, and scientific notation, especially when we're using measured numbers that are either very large or very small, then scientific notation is useful. So here in this picture, you can see a couple of students walking to their class, I assume. The time is recorded as 8:30 a.m., so that's a time measurement. The temperature is also listed, mass is listed, and then a length measurement, meter, and then another length measurement, which is also referred to as distance. All right. So basic units of measurement are length, volume, mass, temperature, and time. Now the SI is an international system of units based on the metric system. So the world over metric system is the system in use. Britain and the United States have dual systems. Okay, so especially if you look at your food packages, the packaged foods, both systems of units are listed on that labels. Okay, so the metric system is an easy system because of the fact that it's all the conversions are in units of 10. All right, so it makes it very easy to use it. Based off this metric system is a modified version called the international system. Now this is a worldwide standard. Why do we need a standard? For example, if you're making a measurement in the US and making measurements somewhere else in the world, you have to have some uniformity in the way those measurements are being made. All right, and so we have a standard system, and that's abbreviated as SI. Okay, and that applies to all measurements of length, volume, mass, temperature, and time. All right, so the basic unit for length is the meter. For SI is also the meter. Volume is liter for metric, whereas it's a larger unit for the SI. It's a kiloliter, 1,000 liters, which is a meter cube. Mass as well, it's grams for metric, but it's kilograms. 1,000 grams is a kilogram. Celsius, I prefer centigrade. So it's degrees Celsius for metric, and Kelvin. All right, Kelvin is used mainly for scientific measurements. Okay, second in both for time. Now here you have two pictures, one of a meter stick and another of a yardstick. If you look at the meter stick, 100 centimeters is a meter, and so all the main markings are in centimeters, but the smaller markings are in millimeters. So you have 10 small markings between the major markings, and so that's 10 millimeters to a centimeter. Okay. The yardstick is 3 feet long. 1 foot is 12 inches, so 36 inches, because 3 feet is 1 yard. And so there is 39.4 inches to a meter, and so the yardstick is slightly smaller compared to the meter stick. Okay. And then another equivalence that you have here between inches and centimeters is that 1 inch, if you look, it's kind of here between 2.5 and 2.6. So again, this is 2.54 centimeters to an inch. The volume measurement for SI is in, as I said, kiloliters. So that's 1,000 liter, and this is a graduated cylinder that is calibrated to 1,000 liters, all right, which is the SI unit, the kiloliter. Now the equivalence between mils and quarts, all right. So there's 946 mils to a quart. So 1 liter is a little bit bigger than a quart. It's 1.06 quarts. Okay. Mass for the SI is in kilograms. Now here, this little top loader, this electronic balance, which gives you a digital readout, it wouldn't be appropriate to make kilogram measurements because it's small. You would have to have a bigger instrument to take larger measurements of mass, right? And this is okay in the lab because you're only measuring in smaller masses in terms of grams, all right? Now the precision of this instrument, this electronic balance, is two digits after the decimal point. When you weigh something, what should you record? You should record all the visible digits that you see on the readout. Okay. So a kilogram is 1,000 grams, and the equivalence between kilogram and pounds is 2.20 pounds to a kilogram, 454 grams to a pound. Okay. We'll come back to these. These are called as the conversion equalities, and then you'll write them in fractional form to get conversion factors in order to convert one unit to another. But we'll get back to it. We'll discuss that in a little bit. Okay. The temperature scale, as you can see here, there's dual scales because of the fact that in the US both scales are used, but of course scientific measurements are only done in Kelvin and or in degrees centigrade. Okay. So the temperature scales are calibrated with respect to water, the melting point of water, which is 0 degrees centigrade, and the boiling point, which is 100 degrees centigrade. Okay, so the lowest possible temperature for the Kelvin scale is 0 K, and therefore the Kelvin scale is positive always. All right, whereas in Fahrenheit and Celsius, you do have negative temperatures. The other difference here that you can see is the symbols. All right, there's a degree symbol for Fahrenheit and Celsius, but Kelvin doesn't have that degree symbol. Time measurements, the metric and SI is both second, is the basic unit, and then you have, of course, minutes, hours, days, and years, and so on. So what is the SI unit for the following? Volume, all right? Volume in SI, as I explained, is a larger unit, and it's the kiloliter or the meter cube. Mass is, again, kilograms for SI. Length is the meter for both, and then temperature is Kelvin for SI. So this is a study check problem. So in a typical day, a nurse is encountering several situations. State the name, type of measurement, and the units of each of the following. A patient temperature is 38.5 degrees centigrade. So this is a temperature measurement in degrees Celsius. A physician orders 1.5 grams of cefuroxime for injection. So this is a mass measurement. The unit is grams. A physician orders 1 liter of sodium chloride to be given intravenously. And so this is a volume measurement in liters. A medication is to be given to a patient every 4 hours. A time measurement. The unit is hour. So whenever you have a measured number, you have a numeric value and then a unit associated with that number. All right, the unit tells you what type of measurement you are doing, whether it's a length measurement. If you see centimeters and meters, it's a length measurement, or if you see liters, it's a volume measurement, and if you see grams or kilograms, it's a mass measurement. Now in any measurement, there is going to be uncertainty in that last digit that is recorded, and that digit is called as the estimated number or estimated digit. All right, so here there are 3 measurements. The last digit is the estimated. This is the digit you kind of take a guess at. All right, so you look at what you're seeing visibly and then you are estimating this last digit. All right, so 5 is the estimated digit here, 5 is the estimated digit here, and 0 is the estimated digit in 3.0 centimeters. All right, so coming to the picture A. Okay, so there are no in-between smaller markings like you see here. Okay, so you're guessing where your measurement falls. All right, so it falls between 4 and 5 centimeters. It seems to be in the middle here. So you take the space between 4 and 5 and divide it up into 10 equal spots. All right, so 1, 2, 3, 4, and then 5. So you'll estimate this as being 4.5 centimeters. Now here, when you do have clear in between markings, then you know that what you're measuring is falling between 4.5 and 4.6. So you'll again take that space in between that 0.5 and 0.6 and divided it up into 10 equal positions, and then again you'll guesstimate that is falling right in the middle, and therefore this should be 4.55 centimeters. All right, so in any measurement you will record what you can visibly see and one more digit that you're estimating. All right, so for example here you won't just record this as 3 centimeters, you would record this as 3.0 centimeters. So you'll have to have one extra digit beyond what you're visibly seeing. All right, so you always have to have that one extra digit, which is the estimated digit. All right, sig figs or SFs, as they're abbreviated, are all of the digits, including that estimated digit in a measurement. All right, now the key part here in determining sig figs, there are some rules, and that concerns which of the zeros digits are significant and which of them are not significant. All right, so we'll talk about that in the next video.